Hi, welcome back. In this set of videos, we're going to be looking at solving absolute value equations. And before we can look at solving absolute value equations, we want to look at what the absolute value operation is. The absolute value of a number is its distance from 0 on a number line, and we write it as the absolute value of x, where absolute value is written as these kind of long bars around our value. Absolute value is always a non-negative number. When we're talking about distance, distance is always positive. So if I have my number line 0, and I have some number, say 7 on my number line, absolute value, the absolute value of 7 is saying how far is it from 0 to 7 on the number line? And the answer is 7. To get from 0 to 7, I have to go 7 units from 0. Now, if I'm looking at the same number line and I'm looking at a value of -7, the question is how far from 0 do I have to go to get to -7? And the answer is 7. -7 is 7 units from 0. We are basically removing the sign and making it positive because distance is always a positive value. So the absolute value of a positive number is a positive number, and the absolute value of a negative number is a positive number. Another thing to think about when I'm looking at absolute value is how does this operation fit into my order of operations, or PEMDAS? My absolute value are going to be a special case of parentheses. These are a special case of parentheses in which you may not distribute anything into or out of. So absolute value are parentheses, but they're more like brick wall parentheses. Nothing goes in, nothing comes out. You have to deal with everything that's inside the parentheses, and then we can deal with the parentheses or deal with the absolute value and continue on with our order of operations. But these are brick wall parentheses. An example of how we would use absolute value is if we're looking at something like -4/3 minus the absolute value of 2y plus 1 if y is equal to -2/3. Our first step when we use evaluate, remember that's substitute and simplify. So I'm going to substitute -2/3 in. So I have 4/3 minus the absolute value of 2 times -2/3 plus 1. So using PEMDAS, if absolute value are parentheses, I need to deal with the parentheses first. Remember, these are brick wall parentheses, so I can't distribute this negative in. So I'm going to simplify what's inside first. So I have 4/3 minus the absolute value. 2 times -2/3 is -4/3 plus 1. Now, -4/3 plus 1, this becomes 4/3 minus the absolute value of -4/3 plus 3/3. So this is -4/3 minus the absolute value of -1/3. Now that I have simplified what's inside my absolute value, I need to handle the absolute value. What that means is that I'm asking myself, how far from 0 is -1/3? And the answer is that it is +1/3. So the absolute value of -1/3 is the same thing as +1/3. So I'm now going to come up here and keep working. So this is -4/3 minus, and I'm replacing this negative is on its own. It's not being affected by the absolute value. So I'm just going to replace this term with +1/3. So this absolute value of -1/3 became +1/3, but this negative value in front of it is not affected. So now I have -4/3 minus 1/3. This is -5/3. That's going to be my answer. So when I fully simplified, I'm going to simplify what's inside the parentheses. I'm going to then deal with the absolute value, which does not include any coefficients in front of it. And then I'm going to do my final simplification outside.